dou square by dou z square. Okay, plus k square of psi is equal to 0 because I have a three-dimensional box. Three-dimensional box, so del is 3 dimensions. Okay, and the psi is the wave function of the particle. Now the wave function of the particle can also be separated as the x component, y component, and z component. So psi is equal to psi x into psi y into psi z. So this is how I have psi. Okay, so when I substitute del, okay, with the dou square by dou x square plus dou square by dou y square plus dou square by dou z square, and psi with psi x, psi y, psi z, that will be a differential equation. Okay, which seems to be very complex, but we have a very simple way, that is through variable separable form. Through variable separable form, okay, I can reduce it, or to say I can reduce it into three different differential equations. One single differential equation can be represented as three differential equations, and the solutions of these equations are given like this. Okay, again, the boundary conditions. What are the boundary conditions? The particle cannot exist at x is equal to 0 or x is equal to L. Okay, the particle cannot exist at y is equal to 0 or y is equal to L, and so on, so on, so on. Okay, and in the same way, it exists between 0 to L of x, and it exists 0 to L of y, and it exists between 0 to L of z. So it exists in these limits, and it cannot exist at the boundaries. Now, when I apply these conditions, I get okay, b is equal to 0, this b is equal to 0, d is equal to 0, f is equal to 0, and k square is equal to kx square plus ky square plus kz square, where k is nx pi by L, and ky is equal to ny pi by L, and kz is equal to ny pi by L. From these things, okay, this seems like a equation of a sphere. Okay, and when I substitute, okay, every k with nx pi by L, okay, and this k with n pi by L, okay, what I get is, okay, I see it seems like okay, n square is equal to okay, k square is equal to n square pi square by L, and kx is equal to nx pi by L. So substituting these things, I get n square is equal to nx square plus ny square plus nz square, where n is taking only positive integers. N is taking only positive integers. Okay. Now this is the condition, and okay, when I try to apply the third condition, integration psi star dx is equal to 1. Okay, I get psi x psi y like this, and finally the particle in three-dimensional box, satisfies this particular wave function. Or the particle in three-dimensional box is represented by this particular wave function. Okay, now that's it. Okay, nothing much over there, nothing much complexity over there. Okay, just extended it to 3 dimensions. Now, what did we infer, or what did we actually get from this, is something which we are going to see today. Okay, we have seen that, okay, k e is equal to n square pi square h cap square by 2ml square. Okay, because k square is equal to me by h cap square, but k square is equal to nx square y plus ny square plus nz square pi square L by L square, or k square is equal to n square pi square by L square. Okay, all these terms are being used here. Okay, en is equal to n square pi square h cap square by 2ml square. All right, but what is n square? N square is as such nx square plus ny square plus nz square. But what values can nx, ny, and z take? Okay, they can take 1, 2, 3, 4, and so on, right? Okay. Now, when you have seen this, what is E1 equivalent to? What is E1 equivalent to? You got 5 seconds. Okay. You need to tell me what is E1 when n is equal to 1. Okay, I'm talking about n is equal to 1. Okay. Okay, E1. I don't have n is equal to 1, but okay, I'm talking okay, first energy level. In the first energy level, what will be the value of? Okay, I'll do one thing. Okay. Anyway, it's given here. Okay, right. Okay, let me say E0 is equal to pi square h cap square by 2ml square. Okay, and n square is equal to nx square plus ny square plus nz square. So what will be the first energy value? Okay, ground state energy. What will be the value of the ground state?
3 pi square.
Yes. Okay, who answered it?
Chandana sir.
Chandana, can you please tell me how?
First energy level we'll have Nx is equal to 1 and Ny is equal to 1 and Nz is equal to 1.
Beautiful. Good. Okay. So here E1 does not implies 1 E naught. E1 does not imply 1 E naught. The ground state, okay, here implies Nx is equal to 1, Ny is equal to 1, and Nz is also equivalent to 1. Am I okay? Very good, Chandana. Thank you. Okay, did everybody understand? So here the value is okay 3. Okay, it is 3 times of E naught. Okay, in the blank case, okay, you have to write it as okay 3 times of E naught, and Nx is equal to 1, Ny is equal to 1, and Nz is also equivalent to 1. Am I clear? Okay, somebody please answer. Is that clear?
Yes.
Yes, sir.
Okay. If that is clear, will you please tell me what will be the next, okay, first extra state energy? You got 10 seconds. 10, 9, 8.
12 pi.
Yama?
12.
Amma?
12, sir.
12.
12, huh? Okay, very good. But it is not so. It is not first excited. I can say it is second excited. Yeah. Yama? The third excited rather. Chepama? Okay, come on. Use your brains. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, nobody answered. So I'll give you a hint. What all values can Nx, Ny, and Z take? And should they be equal? If
So
you answer
positive
these
only,
questions,
sir.
Yama?
Sir, positive.
Yeah, positive what?
Integers.
Integers. Right, good. First question is answered. Second question, should they be equal?
No, no need.
No, sir.
Ah,
Not
okay.
necessary.
Now tell me,
9 in not, sir.
Yama?
Uh, First excited state energy 9 E naught. Is it 9 E naught?
No.
16 also.
Out here.
6
Amma?
not.
6 E naught
6
is
E
the right
naught.
answer. How did you get it? 6 E naught is the answer. How did you get it?
In one axis it will rise and in other two.
So Nx is equal to 1, Ny is equal to 1, and Nz is equal to 2. Yes or no? When Nx is equal to 1, Ny is equal to 1, and Nz is equal to 2, you will get, okay, the first excited state to have 6 E naught, that is 2 square plus 1 square plus 1 square. Okay, but is this the only way to get it?
No,
It can be 2 and 1 also.
Yeah, it can be 2 1 1 also, and
1 to 1.
1 2 1,
1 2
and
2 2 2 also, sir.
how many different ways can you have?
6.
Yeah, how many different ways can you have it like that?
No, 3 only, sir.
Good, 3 only.
3, sir.
Okay, so
Yes, sir.
these are the
3.
3 different ways in which you can have, okay, Nx, Ny, and Nz values to give you same 6 E naught energy. What do you call them? you learnt in your intermediate chemistry.
So what is the question? Can you repeat?
Okay, there are three different ways of Nx, Ny, and Z, because of which you will have the same value of energy. Okay, now every combination of Nx, Ny, and Z will be an energy state. That means a particular state where a particle can exist. Okay, so you can have a particle in 112 state, and you can have a particle in 121 state, and you can have a particle in 211 state. That means you can have three particles, and these three particles are having the same energy 6 E naught. Now, what do you call this kind of energy aspect?
Degenerated.
Beautiful, degenerated energy levels. Intermediate second, okay, intermediate lo I think you have learned it in your chemistry, right? I don't know about physics. Right. So these are the three different degenerate energy levels for the first excited state. These are the three different degenerate energy levels for the first excited state. Okay. What about the second?
1 to 2.
1,
2
2,
2.
2. So what's the energy? 9 E naught.
Yeah. 9
Energy is 9 E naught. In how many ways can you arrange it?
3.
3 ways.
3 ways.
3
3.
ways.
Anyway,
Again, the second excited state is also degenerate by 3. That implies it has got 3 degenerate energy levels. Okay. Now, what about the third excited state?
12.
2 2 2 2.
12.
Yeah,
12 E
12 E naught. Okay, how many different ways can you arrange?
Only one.
Only one way.
Only one way.
So, what about the third excited state? Is it degenerate or not?
No.
No, it is not degenerate energy. It is a non-degenerate energy, right? So how is the energy now? 3 E naught, 6 E naught, 9 E naught, 12 E naught, and so on, so on, so on. Kada? Right? So this is how you have discrete energy levels along with degeneracy, Okay, so when we go for particle in three-dimensional box, the advantage of the particle in three-dimensional box is that it also, it not only tells you degenerate energy part, but also it gives you the mathematical reason for degeneracy. In chemistry, you have accepted that there will be degenerate energy levels, but you might not have ever come across why there should be degenerate energy levels. Okay, this is the mathematical reason why some of the energy levels show you degeneracy. Am I clear? Am I clear, Amma?
Okay.
Okay, good. Now I'm going to ask you some questions along. Okay, from whatever you have already seen. Okay. Now, between the ground state and the second excited state, how many energy states are there? Between the ground state and the second excited state, how many energy states are there? 5 seconds. 5,
1.
4, 3, 2,
Oh, sir.
1. Okay. Ground state and second excited state madhyalo? First excited state.
1.
Okay,
First
good.
excited
Sir.
state is
Now, between the ground state, from ground state to second excited state, what are the total number of energy states available? What are the total number of states, that are available? Energy state
sir.
available where the particle can exist, okay? So the question is
3,
how many,
sir.
yeah?
3 sir.
3.
No,
3.
no.
6,
So
sir.
ground state and second state right now.
It is 9, sir.
From
9.
ground state to second excited state, that means second excited state is also included. How many energy states are
9.
available?
9, sir.
6,
Indama?
7, sir.
sir.
7.
Okay, who said 9? Okay, the person who has said 9, okay, is it, do you stick to 9 or do you change it? Sorry, okay. In the first ground state, we have 1. In the first exercise state, you have 3. That is 1 plus 3, 4. Plus in the second exercise state, again, you have 3. That is 3 plus 1. That is 7 energy levels. Right? Okay. Now, between, okay. Now I'm giving you some value. Okay. Okay. Between the energy 7 E naught to 7 E naught to 13 E naught. How many energy states are there? Okay, between 7 E naught to 13 E naught, how many energy states are there? 5, 4, 3, 2, 1. Anybody? 5, 4, 3, 2, 1. Okay, I said from
We don't
yeah.
have 13 in not
Enama?
7 in not. Can we have
How
7
many?
in not 13 in not?
Okay, question. Okay, కావాలనే confuse చేశాను. Okay, from 7 E naught to 13 E naught, how many energy states are available? From 7 E naught to 13 E
4,
naught,
sir.
states are available. Yeah.
4, sir.
But how can electron or anything, a quantum particle be in 7 E naught? Like it takes.
Yeah, it cannot be in 7 E naught. I accept that. I accept. Yeah. So.
Like this much amount of
I did
energy.
not ask
If
you,
it's
okay, how
in
many
ground
energy
state.
states are there in 7 E naught and 13 E naught? I am taking you, okay, how many energy states are available between 7 E naught to 13 E naught?
2, sir.
4,
Okay,
sir.
how many energy states are, okay, I mean, how many, energy states are allowed?
1, sir.
One is, okay, 9 E not allowed and another is 12 E not allowed. Others are not allowed. When you have allowed energy levels, check whether they have any degeneracy, right? Okay, 9 E naught has got 3 degeneracy and 12 E naught has got only 1 degeneracy. So what is the total number of energy states available? 4.
4.
Understood or not? Don't accept if at all if you have not understood. I gave you the limits from 7 E naught to 13 E naught. Okay, I know that there are no energy levels at 7 E naught. I know that there are no energy levels at 13 E naught. But between 7 and 13, you have one energy state, okay, which is okay, one energy level that is 9 E naught 1, and you have another energy level with 12 E naught. Okay, now 9 E naught 1 is degenerate by 3, and 12 E naught 1 is degenerate by 1. So totally 3 plus 1, 4. Okay, we have 4 okay, energy states between 7 E naught and 13 E naught. Those 7 and 13 do not have energy levels. Okay, am I clear?
Yes, sir.
Okay, right. So from what you see over here, you can say that the number of energy states that are available are nothing but the different combinations of Nx, Ny that are Ny, Nz that are possible. Okay. What are the different combinations of Nx, Ny that are possible? All those actually give you the number of energy states that are available. So between 7 E naught to 13 E naught, there are 4 different combinations of Nx, Ny, Nz that are possible. So we say that 4 energy states are there between 7 E naught and 13 E naught. Okay, that's how we say how many energy